Okay, let's get started. Okay, not working. Okay, in this particular session itself, I'll be covering these four particular agenda. I'll give you a quick introduction about GIC. I will be walking you through about the investment process that will form as a backdrop in appreciating how machine learning analytics is actually being applied in the investment process. So very quickly, for those who are non-Singaporean who do not know GIC, we are a global long-term investors. We are established in 1981. We invest globally in all regions and sectors, with the exception of Singapore. And we invest in a wide range of asset classes. Now, our mission of GIC is to preserve and enhance the international purchasing power of the reserve placed under our management. And what it means is that whatever returns they are getting, we are supposed to beat. We need to beat the global inflation. So in the recent annual report that was released, the 20 years long-term annual rate of return is about 3.4% over and above the global inflation. In terms of asset classes, one unique capability of GIC is that we have multi-assets ranging from public market fixed income, which also includes FX, commodities, and asset-backed securities, to equities, and then private markets. We have private equities, real estate, infrastructure, so on and so forth. Seldom you have asset owners actually having built expertise in multiple asset classes. That is a capability that allows the company to cross-fertilize and harness capability across different asset classes. We invest globally in different asset classes. I will not dwell too much on this slide. These are all available in our annual reports. Very quickly, to form as a backdrop, is the investment process. Now, a typical investment process typically goes through 5 stages. It begins off with idea generation or sourcing, where we'll be trying to identify trends and opportunities. At the same time, we'll try to formulate hypotheses, and then we'll conduct research on this hypothesis. Now, once we have those investment ideas, that's where we go into a due diligence stage, where we'll do a lot of different types of analysis to actually build a conviction about our investment ideas. So we'll do back testing using data. We'll perform all forms of different scenario analysis, stress test analysis, and then we have all these strategies coming together to actually form a portfolio, and we'll do portfolio constructions. Now, once we actually form a conviction, that's where we will actually go to the next stage, where we'll present our ideas and our studies to our investment committee to actually convince our management to actually invest behind the ideas that we have. So that is the period where management will try to poke around to ensure that the robustness of the research that is being done and the conviction aspect. So once management actually have the buy-in, that's where we will put money to work, where we actually trade in the market and express that as trades. So what happened after you actually executed your trades in the market? There must be ongoing portfolio performance monitoring in terms of your exposures and the risk monitoring. Last but not least, periodically, we will always review our conviction about the ideas and strategies that we have. At the same time, we have done the right analysis to actually think of when we want to actually divest from our positions. So in a nutshell, these are the typical 5 stages process in our investment process, and is typically supported by different forms of analytics, machine learning, and quantitative-based models. Now, given the fact that GIC actually invests in a very wide variety of asset classes, I would say that the kind of analytics or the machine learning techniques in use will vary, right? Each asset class is different. Now, very quickly, I will now start to share some applications of machine learning with reference to the investment process. Now, when we talk about machine learning, right, often than not, we know that it's typically used to predict something or to classify something. Now, in the investment space itself, what do you think we will be predicting or classifying? How many of you think that we will likelihood be predicting the S&P index level for tomorrow? Can I have a show of hands who thinks that we are using machine learning in that manner? Anyone? the answer I think is clear, right? Is no. If ever I have one machine learning model that I can actually predict what is the S&P level prices for tomorrow, it's likelihood that I'm trying to also tell you what is the total number or the 4D number that will be coming out tomorrow, and it's I will be quitting my job, running my own model and investing my own money. So definitely, right, we are not using machine learning to predict the stock prices tomorrow, right? So given that backdrop, right, so how do we use machine learning? And other than predicting and classifying, what other modes of application do we have? So in the next few examples, I will be actually sharing with you guys how we actually use machine learning. Sorry. Okay, what you are seeing on screen now is a recession model, right? Given the kind of economic regime they are at with trade war, Brexit, all the different political dynamics that's at play, in the industry, we are talking about late cycle, we are talking about likelihood of going to a recession. So being in GIC, we do actually do a lot of different analysis about the economic regime. This is one example where we built a model using machine learning techniques to try to actually take a look at the regime risk on, risk off timing. Right. So what you can see from this chart here, the gray colored area, NBER defined recession periods. NBER stands for the National Bureau of Economic Research. So there is official definition of when the recession starts. So the blue line that you're seeing here is actually the output of our models. So you can see that generally our model will be able to have some leading aspect of the identification of a recession regime. Below are just the features that's actually used, right, in this particular model. So SVM, right, for those who are aware of machine learning. So support vector machine is the algorithm that's used here. So this is a snapshot that was taken a couple of months ago. So back then, 13% probability of going to recession. So I'll need to caveat here. Please don't go around sharing or telling people that GIC is thinking there will be no recession in the next year, right? This is just one of the data point or the analysis that we have. In order to make our conviction, it's a combination of a lot of different perspective and analysis in order to form a view. This is just one of the model or the analysis that came up with, right? So please don't get too excited quoting from this presentation. Now, the next thing that I will share is another application of machine learning, which I call feature importance. Now, in the traditional investment space for discretionary bottom-up managers, right, they will know typically through experience what are the drivers of their investments. Now, with data science and with the proliferation of data being commoditized, there are now machine learning can be used, right, to actually identify the importance of these variables, which an investment manager would then be able to actually see whether what they believe in and through their experience, is it coincides or align with what the data is telling you. Our job here is to use from a data perspective to actually inform investment managers the drivers of their investment decisions. So there might be blind spots that they are not aware of through the application of machine learning and showing feature importance. That's where we hope to actually uncover any of these blind spots or any abnormality that actually allows the investment manager to be able to dive in more deeply to investigate whether there's any anomaly. Now, in this chart that you're seeing is related to mortgage-backed securities. Mortgage basis is actually defined as the spread between mortgage-backed securities versus the US Treasury. So here, the investment manager actually come up with some drivers that they think will have material impact in understanding mortgage basis. So what we do is to actually have all these different factors based on the investment manager's experience, coupled with other factors that may actually matters to or become the driver, and we run it through an algorithm, in this case random forest. So the byproduct of a random forest algorithm will actually give you variable importance. From the variable importance itself, an investment manager will be able to then say validate, right? Whatever that I believe in or my views, that is that coincide with what we are seeing from a data standpoint. Right. Sorry, keep jumping to. All right, next, NLP. I think Wilson has mentioned in the ICOM platform as well, natural language processing. I must say that in the financial industry, a lot of asset owners or investors has been using NLP as a technique as part of their investment process. So, sorry, I really need to remind myself not to click N. So NLP, I will use this as an example, right? Tesla. So in the Q1 2018 earning calls of Tesla, there are analysts who actually question Elon Musk, right? Hey, how do you actually, what is the capital requirement? And his response is, excuse me, next, boring, right? The question is not cool, right? Next. Right? And another analyst also asked similar question or rather a different set of question, and his response is, we are going to go to YouTube, right? These questions are so dry, right? It's killing me. So can you all imagine with that kind of response, what will happen to the stock price? Right? Immediately after Q1 2018 earnings call, right, with those responses, you get to see a sharp dip in the share prices itself. So how is NLP being used by investment firms? I would say that traditionally for a bottom-up investment managers, analysts typically will cover bottom-up, right, with cash flow analysis, looking at the financial statements, talking to the CEOs, interview the CEOs to really understand a particular company in depth, right, with great depth. But a particular analyst only have a finite amount of time. How many companies can you really cover to that level of depth? That's where technology, data science comes in, right? So now with NLP, it actually allows us to actually process a whole wide universe of companies and stocks to look at sentiment analysis, right? So that you can actually have those insights coming in very quickly, right? So that for certain companies, it may go into your watch list or in your filter very quickly, right? So this is the kind of analysis that we do, right? We perform sentiment analysis on, say, the call transcripts, and we actually perform analysis at a sector level. And you can see quite clearly, for certain sectors, obviously, during GFC stand for Global Financial Crisis, there's a huge dip in financials and real estate, which is what we have seen. That gives us confidence that the NLP technique that we are using and things like that are aligned with expectation and is actually performing and working. And if you were to look at the graphs here, you can also see that there are certain sectors like biotech who are actually more resilient in a recession crisis scenario. Next, other than sentiment analysis, which is quite popular, another example that I would like to actually share here is about topic classification. And to understand this better, I will actually highlight the example of when you file a complaint to government agencies. Do you recall the time that you actually file a complaint or feedback to government agencies and basically you're being routed from one department to another department, from AVA to NEA to Ministry of Health, and then it just keeps cycling, right? Then the government actually utilizes technology using topic classification to now actually process your complaints and feedback, to actually do topic classification such that it will be the output basically is how much percentage of this particular content is actually more AVA related or NEA related. And because of that quantification, that's why you can actually route your complaint to the right government agencies to actually attend to your feedback. Same situation here. Now, in a particular company, if you actually follow the GICS classification, so this is the Global Industry Classification Standard, every single company are being classified, right, by this particular classification in a particular sector. So for Amazon, for example, do you classify it as retail or do you classify it as tech? Right? I think nowadays, as we evolve, companies are getting so sophisticated and they are involved in multiple lines of segments of business. Right? So we use topic classification to actually look at their SEC filings, the descriptions, to actually try to come up with a quantification of about company, what kind of sectors they are being exposed to. So you may think, oh, so if I were to know Amazon is X percentage to technology, Y percentage in consumer, what does it matter to investors? We can do a lot of things. Firstly, from a risk standpoint, right, you will be able to get a more true reflection of your risk exposures. So if I were to ask you, a particular portfolio manager, what is the exposure to healthcare? What is the exposure to technology? Right? It will be a more accurate picture rather than the traditional manner, which is actually based on what the industry have classified a particular company, which often than not is belonging to only one classification. If I were to actually do my investment, let's say I wanted to make sure that I pick certain stocks in a particular sector, right? So I wanted certain exposures to certain sectors itself, right? Because of this capability, it also allows me to actually say that I want to limit my exposures to say tech or healthcare using this data. So this is another application of NLP, which is typically forgotten. Right? Normally NLP, people always talk about sentiment analysis. This is a different application using topic classification. Next up, I would like to just touch on analytics that is used in investment. This is actually Siri. Have you ever wondered that when you actually talk to Siri, how come Siri will understand what you're saying? In a nutshell, there are algorithms behind it that is actually recognizing your wave patterns. So when you talk, there are tone, there's the duration, there are different wave patterns. The algorithm in play here is actually called dynamic time warping. Right? So there's a pattern recognition pattern matching algorithm that matches the wave patterns, right, and associate with words. In this case, we kind of apply this to asset prices and returns. So in this example, imagine the 65 days asset returns or patterns, right? We make use of the dynamic time warping algorithm to actually look through history similar patterns. And from there, we actually say that every time this pattern happened, what happened to the next 65 days? Then we will be able to actually form a distribution, right? A probability distribution about typically similar wave patterns that happen, what is the general trend of the asset price and the returns. So this is actually something that we use more from an appreciation of the general trending of how our asset and returns will go to. Next, there are 6 graphs here. How many of you actually is able to single out which one is the odd one here? Anyone? Actually, to a human eye, all these 6 might look different, but to the system standpoint, these are all the same graph. This is the property of graph isomorphism, which I'm going into network analytics and graph analytics. So you may wonder, how does network analytics come into picture and how we use and apply them in the investment space. Now, imagine you actually have the supply chain data of a company, right, whereby you have the suppliers, the customers, the suppliers, and so on and so forth. Now, one way of application will be some form of pair trading. So the hypothesis here is that companies with similar supply chain data, customer and supply relationship, they should trend the same. But how do I actually identify which 2 companies or more companies is actually having the same or similar supply chain network? Right? Humanly, it is actually quite difficult to achieve. But with graph analytics, with graph databases, all these are made possible. You actually fire a cipher query using Neo4j. Very quickly, you will be able to identify companies that are similar based on the property of supply chain. Then you can actually do some form of pair trading. So if there's a particular company that is way too much off his peers, right, you will tend to be able to make a decision to do the opposite from a trading or a standpoint. This is another example where we kind of combine NLP and network analytics. 4 years ago, Volkswagen actually have an emission problem scandal, which I don't know how many of you here still remember. That incident actually sparked off an internal capability built up about using NLP and network. So what we wanted to do here is that given a particular incident, so let's say about Volkswagen, we wanted to actually be able to scan through all news and pick up what are all the companies that are actually impacted by this particular event, right? So we do news scraping using NLP, entity recognition, to pick up what are the different companies. And in order to understand the domino effect or impact as a result of this particular news event or scandal, that's where we go into the supply chain data to actually find out what is the +1, +2, or +3 impact analysis, right? So this is actually an example of how NLP techniques and network analytics actually come together to serve an investment function. Last but not least, I would like to actually also touch on about in-house analytics. This is not designed or invented by GIC, but it is something that we actually capture and notice it in one of the Strata conference that we actually attended. Now, the nice thing that we like about this fish diagram is that in one particular diagram itself, it actually covers multiple attributes, right? So the eyes of the fish can represent the returns. The bigger the eye, the higher the return, right? Each part of the body of the fish can represent a dimension, right? So in this case, the top part of the fin can be talking about region exposures. The tail of the fish can actually represent sector exposures. So can you imagine every single portfolio is in the shape of the fish? Visually, it's very easy for someone to remember. Why? Because you can actually look at the fish. So there are some thin fish, there are some eyes that are bloated, there are eyes that are very tiny and small. Basically, at one glance, right? Today, when I actually ask my portfolio managers, I ask my own team members, they will actually be very quickly able to tell me what is my sector exposures, what is the market cap, what is the region exposures. Why? Because visually, they remember how the fish look like. And every different portfolio will look differently, just like all the fishes that we catch in the market. I mean the deep sea. All right. So that will be my last example of how analytics is actually being used in GIC. With that, I'll end my speech here. Thank you.